Let us do a beautiful sum, a very interesting one. Let's see the sum. We have a figure here and the sum information. It says that quadrilateral DEFG is a square. In triangle ABC, we have angle A given as 90 degree. Prove that D square is equal to BD into EC. This is what we need to prove. Okay. Now, when we look at the two proof, it seems to be very difficult. No, but it is going to be very interesting. Now, let's analyze this two proof to understand how to approach the sum. It says D square equal to BD into EC. Isn't this in the form of a product equal to product? You remember product equal to product, because if you look at the left hand side, it is D square, means it is DE into DE, right? That is equal to BD into EC. Actually, what we have here is a product equal to a product. And we have already learned when we want a product equal to a product, two products will be equal when two ratios are equal, and two ratios will be equal when two triangles are similar. So from this, we need to identify triangles so that will give us the two products, right? Now when we look here, one thing we realize is we want BD, we want EC, we want DE, right? With the help of this, we'll never get triangle because they are all collinear, they are on one line, right? So one thing is, observe here, BD, EC, keep it as it is. D we want it twice, but D is not going to give us a triangle with this, right? But remember, this D belongs to this quadrilateral, and this quadrilateral is a square. And if it is a square, that means all the sides are equal, right? Now we want D twice. So let's substitute this D once as DG and once as EF. Can we do that? Yes, because D is equal to this, right? Because it's a square. So once we are going to replace this DE by GD, and the other time we're going to replace that DE by EF. Let's do that now. So that is what you're going to see the hint there. I'm replacing that. So now 1D, yes, observe. So what has happened is, because of this, now can we get a triangle here? Yes. Can we get a triangle here? Yes. We got the two triangles. Now we are very clear. We'll get this product equal provided we prove these two triangles to be similar. That's the major part of the sum which we had to think. If you have thought this, then the sum is very easy. So you'll say, yes, we got this. But wait, now you got these two triangles here. You need to prove them similar. You'll say, yeah, very easy, right? Observe, you got one angle to be 90 here, you got another angle now. We are very excited. Yes, we got one pair of angle congruent. Can we get one more pair of angle congruent? It is not there. Check. You don't have. You're not getting it directly. That means again we are stuck. We are not getting the triangles to be similar. So how do you think further? It's very interesting now. Observe. So you're not getting them similar, but we need to prove them similar, because if we prove them similar, only then we are going to get this. If you look at the figure, there's one more triangle here. If you see here, this one, you see, this triangle will be our savior. It will help us. You know how it is going to help us? You want to prove them similar, both of them. This triangle will prove it similar to the first one here, and the same triangle will prove it similar to this one. So what happens? By property of transitivity, we'll end up getting this triangle and this triangle similar. Isn't that interesting? So our object is very clear. We want this triangle AGF similar to this first triangle. Then we want to prove this triangle similar to the next triangle, and then get this. Is that clear? So let's do that. So now, in order to get this two similar, what are we going to do? Observe it. If you look at those two triangles first, you have one pair of angle only congruent. Then how do we get them? It's very easy. You have a square here. For the square, we know that GF and DE, they are going to be parallel, because opposite sides of a square, they are parallel to each other. So we write them parallel, right? But this D, instead of D, can I write it as BC? Yes, we can write it as BC because it is B dash, D dash, E dash, C. So we write that. GF remains as it is. Instead of D, we write it as BC. Now for these two lines, this AB, can it act as a transversal? Yes, it can. And if it acts as a transversal, you get a pair of corresponding angles here, isn't it? And that's a pair of corresponding angle. You get this pair of corresponding angles to be congruent. Reason is corresponding angles here. So let's write it. So we write angle AGF congruent to angle B. Just write it with a single letter. That will make our job easy. And that's the result number one. Easy. So that is going to help us to prove these two triangles to be similar, right? Same way, let's pick up something which will help us to prove this triangle and this one to be similar. right? For that, AC will act as a transversal and we'll get a pair of angle here, right? We'll get that angle AFG is equal to this angle, and we got that angle AFG equal to angle C, and that's our result number 2. Beautiful. And the reason for both is one and the same, corresponding angles here. Now we've got everything what we wanted to prove these two pairs of triangles similar. Let's do that now. So we consider this first, in triangle AGF, this triangle and the other triangle, right? Both the triangles we are considering. And now first slide, which angles are congruent? First one which we got there, angle AGF congruent to angle B, that is from 1 we got. Then the other pair of angle which we already have, that is 90, right? That is angle GAF is congruent to angle GDB. And why are they congruent? Because each is 90 degree. So hence we get both the triangles to be similar. We write triangle AGF is similar to triangle DBG. Now this was very critical. Just don't write them similar. Write them as per the one-to-one correspondence. I'll tell you how. This we have already learned. Define one triangle, right? So if I take the name of the first triangle as AGF, write the name of the second as per the one-to-one correspondence. How do we get that? Listen. Here A is 90, here D is 90. That means A corresponds to D, right? Beautiful. Here G is star, here B is star. That means G corresponds to B, and then you have the remaining vertex. So that is how we get the triangle similar by AA test of similarity, and that's the result number 3. So one pair of triangles we got similar. Now we need to get one more. Let's do the same way. So consider this two triangle, triangle AGF and that other triangle. In both the triangles, one pair of angle we already got, that is angle AFG congruent to angle C, which was from our result number 2. And then the other pair is that 90 degrees. So we write that angle GAF congruent to angle FEC. They are congruent. Reason is each is 90. That means now we are saying yes, both the triangles, they are similar. But again, when you write them similar, look at the correspondence. Very important. Right? If this A is 90, which one is 90 here? E. That means A has to correspond to E. Now the other pair of angle which you have congruent there, F is equal to C. That means here F corresponds to C, right? So what is left here? G and E, right? So G corresponds to E. That is why the name of the second triangle would be EFC, right? That is important, and they are similar to each other by AA test of similarity, and that's our result number 4. Now look at result number 3 and result number 4. Observe, triangle AGF similar to triangle EFC, triangle AGF similar to triangle DBC, right? This is what we got. So now triangle AGF is same. That means we get triangle EFC equal to triangle DBG, right? Equal means I mean to say similar to triangle DBG, right? We wrote that. So these two triangles, we got them similar, and that is from statement number 3 and 4, right? This was important. This is what we wanted. So ultimately we have got the triangle similar which we wanted. Now take the ratios which we want. Which ratios do we want? We want DG, we want DF. Let's take that. So when we take DG, that means it's the first and the third. So we take that DG, right, upon EC. We want DG, we want EC. What do we want? EF and BD. So we take that BD upon EF. So you know BD upon EF is equal to DG upon EC. Took the sides. We took those sides which we want. We wrote that, and the reason is CSST, that is corresponding sides of similar triangles. Now once we get that, what do we want? We just cross multiply. Now once we cross multiply, what do we get there? We get there, cross multiply, we get BD into EC is equal to DG into EF, right? Look at the two proof. In the two proof, we wanted BD into EC, we got that. But here we have got EF into EC, EF into DG. We don't want that. We want DG into EF. DG into EF we got. But ultimately at the end what we want is D square, right? Now this EF can be replaced, this EF can be replaced by DE, and this DG can also be replaced by DE. Remember at the start we were doing the hint? Yes. So that's what we are doing now. In the next step, we write BD into EC as it is. EF will be replaced by DE, and DG will also be replaced by DE, right? Why? Because they are the sides of a square. Now we got it. Now we know D into D is how much? D square, and that is equal to BD into EC. So we can write the last step there. D into D, that is D square, is equal to BD into EC, and we write that. That is equal to BD into EC. We got the proof. Was that easy? A beautiful sum, a very, very, very important sum, student.